So in this segment, what we will do is we will try to give a visual meaning of these equations, whatever we discussed now, okay, so that it will be clear in our brains. Now just think that we have a tube, right? So I'll draw a thin tube, and we had a piston over there, and we are oscillating it, and I said that we will draw the displacement, pressure and velocity fields one below the other, so that it will be clearer. Okay, so like that, and it's going to infinity. It's a semi-infinite tube. Okay, fine. So, and then we also said that we will take up a xi plus field which looks something like this. So this is xi. Okay, so 3 half wavelengths we have drawn. Now we were trying to see that if there are some uniformly distributed, let me okay, say 1, 2, 3, 4, something like that. So like that we will try to draw okay, and similarly here. Now if you see this, what it tells me is, let me draw also the tube maybe here, because we want to draw the wave fronts, how they look like, and from that we will try to see whether we are getting the pressure and displacement fields. Now here it is saying us that a negative displacement has happened at this point. So that means the plane which was here, the wave front, it would have come this side, right? Negative. So that means maybe somewhere here it will have come here. Then similarly the plane which is here would have come this side only because it's negative, but by a slightly higher distance than this. Okay, now that means this distance should be less than what it is here, so maybe here, and this one would move sort of this much distance from here, so something like that, and this plane would move this distance from here. Could you see that? So that's what I was talking about. And now if you go to this side, they're exactly the opposite, means they were negative distances. I'll if you want to show. So basically this much is this, right? Xi at this point. Now this one is this. Then this one is again this, and this one is this. Okay, Similarly, if I go on this side, I'll just draw from symmetry, okay, that it will be somewhere here, and let me draw from this side. So here, here, and maybe here, something like that, okay. And then obviously this location won't change anyway, because displacement is 0. And here these are positive displacements. They have gone to that side, okay. Now, what do you see from this? That means air particles, or the planes of air particles, now their closure here, and similarly their closure at these locations. I'll draw in fact this part also to some extent, something like that, okay. So their closure here, and they are rarefied here. So that means obviously the pressure will be high here. Pressure will be minimum at this location, and in between here the pressure will be almost 0. When I am saying pressure now, I am talking always about the excess pressure over P naught. Okay, so this is what the xi plus as a plane, a planar representation. Okay, the planes, how they, the wave front is a technical term. Yeah, and then if we go to talk about, say, the pressure. So pressure is high here, and it's a positive pressure, and here it would be a negative pressure. So if I draw the pressure plus thing, so it will be something like, you know, like this. Yeah. Okay. So this tells me that this is compressed here and it is rarefied here at negative pressure. Okay. And what about then the velocities? Okay. Let's say, okay, let's I'll draw with the white color here, and then I'll draw the vectors in green. Now if I have to draw here, sorry, here, wherever you remember our pressure and our velocities, they were in phase. So wherever there is a higher pressure, we will have a higher velocity also, and in the positive direction. And so here, in a way, we will have a let me say here, so a small velocity here and like that, okay. And here the velocity will be negative and slightly bigger and much bigger, and similar velocity here and slightly smaller, very small. Then on this side, small, slightly bigger and much bigger, and much bigger, slightly bigger, very small, and small, like that. Okay. So this is how the velocities will be. Okay. Sorry, these are u plus. Fine. So this is what I was talking about. Whenever you see those equations, you should have a visualization of this, and obviously this is more demanding visualization than the transverse displacement of a string. Okay, and there you were mostly bothered about the displacement, the y deflection, the transverse deflection, but here we are actually interested in these two very much, the pressure and the velocity, because we will just now we will see that the intensity of the pressure wave or the acoustic wave, that is what is very important parameter, because that is what we perceive. Okay, the intensity, not only the pressure but the intensity. When we multiply pressure times the velocity, so we will get a pressure. We will discuss about them. So that is the parameter which will be of importance. So that is why not only this and then one more difference from the transverse vibration of string is, here we don't discuss much now. After this point, after today's class, hardly we will be discussing any time about the displacements, though we started from that. Displacement will be only crucial from the thought process that, okay, with a piston, if we are trying to get this pressure field generated, then that is the thought process. Otherwise in a field we hardly talk about the displacements. We mostly almost talk about the pressure and the velocity fields. Okay.
Sir, it's because it's the pressure that we perceive.
The pressure that we perceive is not.
So like in the case of transverse, then what?
Yes, yeah, in that way you are saying yes, perfectly. In the transverse wave we see that the displacement. So that's how we always think about that. And here I'll just would like to correct that. We don't perceive pressure exactly, we perceive pressure times velocity, in a way, intensity. Okay. So I mean, it's like force times velocity, right? So energy. So the energy per unit time, sort of, so that power that comes and hits our ear, so that is what we perceive. Okay. So both pressure and velocity, both are important. Okay. So we will stop this segment here, and we will see you in the next segment.